Aeroplanes have made our world smaller, connecting people and cultures. However, flying comes with an environmental cost due to fossil fuels. Burning these fuels releases carbon dioxide, contributing to climate change. The aviation industry is searching for cleaner ways to fly. Imagine a future where aircraft glide through the sky without polluting it. This is the promise of hydrogen-powered flight. Hydrogen is the most abundant element in the universe. When used as a fuel, its main byproduct is water. The vision is clear aeroplanes that produce zero harmful emissions. This would be a giant leap for sustainable travel. The idea of using hydrogen to power aircraft is not entirely new. Scientists and engineers have explored it for decades. Now, with the growing climate crisis, hydrogen is back in the spotlight. Hydrogen flight involves using hydrogen gas as the primary power source for an aircraft. This can be done in a couple of different ways. Both methods aim to drastically reduce aviation's impact on our planet. The journey to hydrogen-powered aviation is a grand challenge. It requires immense innovation and investment, but the potential rewards are equally immense. The sky, it seems, is not the limit, but a new beginning. So why is hydrogen so special for aeroplanes? One key reason is its energy content. Hydrogen packs a lot of energy for its weight. It has about 3 times more energy per kilogram than traditional jet fuel. This is very important for aircraft. Lighter fuel means planes can fly further or carry more passengers and cargo. Batteries, another clean option, are currently very heavy for their energy output. Hydrogen offers a pathway to decarbonize even long-distance flights. The most significant advantage of hydrogen is its environmental performance. When hydrogen reacts with oxygen in a fuel cell, it produces electricity. The only byproduct is pure water. No carbon dioxide, no soot, no sulfur oxides. If hydrogen is burned directly in a modified jet engine, it still produces mainly water. There can be some nitrogen oxides, or NOx, formed at high temperatures, but these are much lower than with kerosene, and technology can reduce them further. Furthermore, hydrogen itself can be produced sustainably. Green hydrogen is made using renewable electricity, like solar or wind power. This electricity splits water into hydrogen and oxygen through a process called electrolysis. Hydrogen is also versatile, used in different types of propulsion systems. There are 2 main ways hydrogen can power an aircraft. The first is through hydrogen fuel cells. The second is by burning hydrogen directly in a combustion engine. Both approaches have their own set of advantages and challenges. Hydrogen fuel cells are like batteries that never run flat, as long as you supply them with fuel. Inside a fuel cell, hydrogen gas, H2, and oxygen, O2, from the air combine. This is an electrochemical reaction, not burning. It produces electricity, heat, and water, H2O. The electricity then powers electric motors, which turn propellers or fans. Fuel cells are very efficient. They convert a high percentage of hydrogen's energy into useful power. They are also quiet and produce zero CO2 or NOx emissions at the point of use. Hydrogen combustion, on the other hand, is more similar to how current jet engines work. Instead of kerosene, specially adapted jet engines would burn hydrogen gas. Hydrogen burns very cleanly compared to kerosene. The main exhaust product is water vapor. Engineers are working hard to design combustion systems that minimize NOx formation when burning hydrogen. The choice will depend on many factors, including aircraft size, range, and technological progress. Despite its promise, hydrogen aviation faces significant hurdles. Storing hydrogen on board is a major challenge. It has high energy per mass, but low energy per volume. This means it takes up a lot of space. Hydrogen must be highly compressed or cooled to a liquid. Both methods need large, heavy tanks. These tanks impact aircraft design and capacity. Infrastructure is another challenge. Airports are built around kerosene. Switching to hydrogen needs new infrastructure. This includes production or import facilities. Pipelines or special trucks are needed. Airports need new storage tanks and refueling equipment. Building this is a massive undertaking. It requires huge investment and coordination. Green hydrogen production costs must come down. But progress is happening quickly. Several companies are making breakthroughs. The primary driver for hydrogen aviation is its potential environmental benefit. Flying with hydrogen power means a dramatic reduction in greenhouse gas emissions. If green hydrogen is used with fuel cells, the CO2 emissions from flight can be virtually eliminated. This is a massive step towards tackling climate change. Even with hydrogen combustion, CO2 is not produced from the fuel itself. While NOx can be an issue with combustion, it is expected to be significantly lower than from kerosene engines, and research aims to reduce it further. Beyond CO2, hydrogen flight could also reduce other climate impacts of aviation. Traditional jet engines produce contrails. These contrails, made of ice crystals, can trap heat in the atmosphere, contributing to warming. Hydrogen planes will also produce water vapor, so they will still form contrails. However, these contrails might be different, perhaps shorter-lived or with different properties, because there are no soot particles. Hydrogen is not a magic bullet that will solve all of aviation's environmental problems overnight. It is likely to be one part of a broader strategy. Sustainable aviation fuels, or SAFs, made from sources like used cooking oil or agricultural waste, are another important option. Improved aircraft efficiency, better air traffic management, and electric aircraft for very short routes will also play their part. Hydrogen is particularly promising for medium to longer range flights where batteries are not viable, and where SAF supply might be limited. The journey towards widespread hydrogen-powered flight will be long and complex, but the destination is incredibly compelling where air travel is truly sustainable.